Hello future engineers, welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends. That's one way you can keep me going, inspired and refreshed. I find my videos interesting and important to your studies. Also, please don't forget to subscribe. Cable BD has a tension of 1000 newtons, whereas the tension in cable CD is 500 newtons. Determine the component parallel to CD of the resultant force exerted by the cables on point D. Express this component as a vector. So we'll first obtain the resultant by expressing its force into vector form. First for BD, F DCX is 500 cosine of 25 because this is 25 times cosine of 20. That's the x component. So 425.83 newtons. The y component is negative. It is 500 times sine of 25. Negative 500 sine of 25. It is opposite to 25-degree angle and it is directed downward. So it is negative 500 sine 25 degrees and it is negative 211.31 newtons. Then for the z component, we compute this component first, which is 500 cosine 25. Then after computing that, we multiply sine of 20 to get the z component. So FDCZ is 500 cosine of 25 degrees times sine of 20 degrees, and it is equal to 154.99 newtons. Then for the other force, 1000 on cable BD, 1000 times cosine 35 first to get the projection on the xz plane. Then the x component is we multiply sine of 20 plus 45 or cosine of 65. 20 plus 45 is 65. So 1000 cosine 35 times cosine of 65 degrees. That's the x component of the 1000 Newton force along DB, 346.19 newtons. Then FDV, y is, it is opposite to 35 and it is going down, so negative 1000 sine of 35. Then FDZ, so it is negative 573.58 newtons. FDZ is positive, DBZ, so this component is 1000 cosine 35. Then since this total angle here is 20 plus 45, 65, and it is opposite to 65 degrees, so 1000 cosine 35 times sine 65. That's the z component. 1000 cosine 35 degrees times sine of 65 degrees. So FDBZ is 742.4 newtons. So we can now compute the resultant, summation forces x, or we add corresponding components. So this is the component of DC 425.83, x component, plus the x component of DB, so plus y component of DC, negative 211.31, then negative 573.58J. Then for the Z component, 154.99 plus 742.4 K. So R is equal to 772.02 I minus 784.89 J plus 897.39 K. The component of this resultant force parallel to CD is by obtaining the dot product of R with the unit vector of CD. So FDC is equal to 425.83 I minus 211.31 J plus 154.99 K. The unit vector is simply dividing this by the magnitude of the force, which is 500. So lambda DC becomes 0.85166 I minus 0.42262 J plus 0.30998 K. So obtaining the dot product of R with lambda DC, that's the component of the resultant along DC. So R times lambda DC times cosine theta, and lambda DC is 1. So it reduces to R cosine theta, which is the component of the resultant along DC. So since the product is by sum of product of corresponding components, so R cosine theta is 772.02 times 0.85166. So that with the unit vector. Then from here, we can compute the magnitude of the resultant along DC. And it is equal to 657.5, which is 425.83 times 0.85166. Then plus negative 784.89 times negative 0.42262. That's the value. Then 897.39 times 0.30998. That's the value. So the magnitude is 1267.38. Then expressing this in vector form, we multiply this by the unit vector DC. So R cosine theta in vector form is the magnitude times the unit vector along DC. So the answer is in vector form 1079I minus 535.6J plus 392.9K newtons. For your part, you have to determine the component parallel to BD instead and express this component as a vector. Then show that this is the answer. So that's your part.